All right, so I'm just going to do the first couple with you. So given the function y is equal to y squared minus 7x, if I want to differentiate with respect to x, so I'm going to differentiate with respect to x, my given. So any variable that isn't x, I need that implicit step. So the derivative of y is 1 times dy dx. And then derivative of y squared is 2y times dy dx. Derivative of negative 7x would just be negative 7. I bring the 2y to the other side and I factor it out. So I get 1 minus 2y equals negative 7. Okay, so I subtracted the term and I divided out what was common in the same step. So then I get dy dx equals negative 7 all over 1 minus 2y. All right, so for this lesson, lesson 2.6, we're going to be deriving with respect to t, with respect to time. So if I take my original and I derive with respect to time, now notice all the variables in the expression are different than the variable that I'm deriving with respect to. So the derivative of y with respect to time would be exactly that, dy dt. The derivative of y squared would be 2y, now dy dt. Now the derivative of minus 7x would be negative 7 times dx dt. Okay, so I'm deriving with respect to t, and the two variables in the expression are different. So I'm still using that implicit step, but now each piece needs that part of the chain rule. Okay, so related rates, rates of changes of two or more variables that are changing with respect to time. So whenever you solve a related rate problem, you're deriving with respect to t. Okay, so here's my function, find dy dt at the given point. So the first thing I'm going to do is I'm going to derive this expression with respect to t. So the derivative with respect to t of this function, okay. So just so we can re-familiarize ourselves with some notation, apply the power rule, 3x squared times dx dt minus 4 times dx dt. Okay, and in words, this means derivative of x with respect to time. Now, what would this be? F of x really equals y. So the derivative of this with respect to time, I would write that as dy dt. So here's my expression. Dy dt equals 3x squared dx dt minus 4 dx dt. Now, let me go back up here real quickly. On the first problem, we could get dy dt alone. We could isolate that. That represents our derivative of y with respect to x. In part B, though, each of our terms have a derivative with respect to t. So notice I didn't solve for one over the other. That really depends on the problem and what you're trying to find. So for these examples down here, I want dy dt, and I'm given specific conditions. So for part A, sorry about that. So for part A, I'll have dy dt equals, that's what I'm looking for. I tell you the value of x is equal to negative 3. So wherever I see an x, I get to replace it with negative 3. Now dx dt, notice this is already a rate of change that's given. So wherever I see dx dt, I'm allowed to replace it with this value that's given as negative 2. Minus 4, dx dt is equal to negative 2. And what you're going to have to be aware of as we do these problems, you're going to be given information that you're going to substitute in for, and you're always going to have one unknown. So here I get negative 6 times 9 plus 8, negative 54 plus 8. So then when I subtract them, so my answer would be negative 46. So now when x is equal to 1, the only thing I'm changing is this value of x into what the derivative is. So 3 times 1 squared dx dt doesn't change. That was given as -2. Minus 4 times -2. So now I get -6 plus 8. So I get a rate of change of y with respect to t to be equal to 2. And for my last one, dy dt equals 3 times 4 squared times -2. That stays the same. Minus 4 times -2. So you get the picture. You plug these numbers in, and then you are just evaluating what the answer is. Okay, so for homework here, this one can be a bit labor intensive, but give it a shot. So I tell you, the variables I use here are x, y, and z. So your volume, you should make it x times y times z, because those are the 3 rates of change I give you. So if you're going to derive this equation with respect to time, this is your product rule, but you have 3 terms there. Okay, so dv dt equals, if I'm going to keep my first 2 the same, I multiply by the derivative of the third. Then I'm going to add that to that. First times my last times the derivative of the middle term or factor, plus now I keep y and z the same and multiply by the derivative of x. Okay, so remember, we only use that implicit step when we're actually applying a derivative rule. So try those last 2 examples for homework.